Hey, how's it going, everybody? It's your bro, hope you're doing well, and in today's video I'm going to teach you everything you need to know to get started using MongoDB in about an hour. So sit back, relax, and enjoy the show. Hey, if you like free stuff, you should probably subscribe because I release free courses every once in a while, when I feel like it. That is all. What the heck is MongoDB? It's a NoSQL database management system that can manage a humongous amount of data. And it's becoming increasingly popular. It's favored by many big tech companies. Unlike relational database management systems, MongoDB uses a NoSQL format to store and retrieve data. NoSQL means not only SQL, it's where data is stored in various formats besides a traditional SQL table. Rather than storing our data in rows and columns with a table using SQL, we store related data as a single document. Think of each document as a single row in a table in SQL. Data in each document is stored as field value pairs, similar to a JSON format, but it's technically BSON, binary JavaScript object notation, but it behaves very similarly for all intents and purposes. The general idea is that data which is frequently accessed together is stored together, rather than in separate tables, because SQL joins, quite frankly, are a pain in the ass. This is how our NoSQL database is arranged. We have a document. A document is a group of field value pairs to represent an object. A collection is a group of one or more documents, and a database is a group of one or more collections. This makes working with and scaling our database like really easy. Before we do begin, there are a few prerequisites for this series. We will be working with document objects. I would recommend at least some experience with an object-oriented programming language of your choosing. It doesn't matter if it's Python, Java, C++, C#, JavaScript, doesn't matter, just pick one. So let's get started. I will show you what you need to download. Alright, let's get started, everybody. Here is the installation process for MongoDB. So go to this website, mongodb.com, go to Resources, Server. On the left sidebar, go to Installation. Here's a list of different installation tutorials depending on your operating system. I'm running Windows, I'll select Windows. Let's scroll down. We're looking for Install MongoDB Community Edition. All you have to do is follow the numbered steps. Beginning with 1, we will go to the Download Center. I'll open this in a new tab because I don't want to close out of this window. Select the current version. Select your platform. Again, I'm running Windows. And the installation package. I'll keep that the same. And download. Pick a place to save the installer to. I'll keep it within my Documents folder, but you choose your own place. And I will open this when it's done. So we're going to click Next. Accept the license agreement. Next. Complete. Install MongoDB as a service. Make sure that's checked. Next. Also be sure to install the MongoDB Compass program. It's a graphical user interface. Then give it a couple minutes. Now that MongoDB is installed, we can finish. This may open Compass. Compass is a graphical user interface for managing our database. We'll be using Compass intermittently. In fact, I recommend creating a desktop shortcut. You just have to open it. Then to establish a connection, you hit the green connect button. I'll be using Compass intermittently just to show you how everything works. Let's also install the MongoDB Shell. To install the shell, we're going to go to the left sidebar, and where is it? There, MongoDB Shell, also known as Mongosh, like oh my gosh. We are going to go to the Download Center, select the current version, select your platform, I'm running Windows, and the package, we'll keep that the same, and download. We'll open this when it's done. We will unzip this folder. So right-click, extract all. We will need the file path to the executable. Let's open this folder. Go to bin. And we can copy this file location. Let's right-click on our executable. Go to Properties. Copy this file location. It should be within the bin folder. Then we're going to add that file path to our environment variables. Really, we can just search for environment variables. We're within system properties. Go to the advanced tab, environment variables. Underneath system variables, let's pretend that this wasn't here. Click new. Come up with a variable name. MongoSH is good. Then paste that file location. Hit OK. OK. And close. So if we go to that folder and open the executable, this is the MongoDB shell. I'm going to make the font size a little bit bigger. To establish a connection to our database, type MongoSH. And that should establish a connection. To clear your screen, type CLS. To exit, type exit. Personally, I don't like using this executable by itself. I like using VSCode. If you would like to use VSCode for using the shell, here's how. So within VSCode, we're going to download the MongoDB extension. So go to extensions, search for MongoDB. It should be this one. We will install this extension. There should be a new icon for MongoDB. Let's click on it. To establish a connection, we just have to click on localhost. The MongoDB connection was successful. Then to open our terminal, right-click, launch MongoDB Shell. Let's minimize this. Close out of this window, pull up this terminal. We are utilizing the MongoDB Shell with VSCode. So to exit, you type exit. To establish a connection, you can type MongoSH. To clear your screen, you can type CLS. And that is everything you need to know to get started. Hey everybody, here's how we can create and use databases in MongoDB. To show all databases, type show DBS. That will give you a list of all current databases. I have 3, admin, config, and local. To use a database, type use, then select a database name. To use admin, I can say use admin. We have switched to dbadmin. Now, if you use a database that doesn't exist, let's say we will create a database for a school. Use school. That's how you can create a database. We are now within a new database named school. However, if I were to show my current databases, my school database doesn't show up. It's not visible because it's empty. We'll need to fill it with something. Let's add a collection to our school. To do that, type db dot. We will use the create collection method. This method ends with a set of parentheses, just like a function or method in typical programming languages. Within the set of parentheses, we are going to pass in an argument for a name for this collection. Let's create a collection of students. And we are returned with, okay, we have created one new collection. Let's clear our screen, show our databases again, show DBS, and here is our new database of school. Currently, we are within our school database, as you can see next to my cursor. To drop this current database, you can type db.dropDatabase method. And our database is dropped. Let's show our databases again. And our school database is no longer there. That is how to use, create, and drop a database in the MongoDB shell. If you would like to use Compass, here's how. We have our 3 default databases, admin, config, local. To create a database, you can click this green button. We'll need a database name, let's say school again. We will create a collection of students within our database. You can add additional preferences, but we'll cover that later. We will create our database. And here's our database of school. There is one collection of students, but students doesn't have any documents yet, which we'll cover in the next topic. To delete a database in MongoDB Compass, select a database from the sidebar, then hit the trash can icon to delete it. Type the name of the database to drop the database. So make sure that the name of the database is typed, then drop database. And that is how to use, create, and drop a database in MongoDB Compass. Alright, we're moving on everybody. Now I'm going to show you how we can insert documents into a MongoDB database. Let's be sure that we're using our current database. In the last topic, we were using the database of school. Let's clear our screen. To insert a document within the database we're working with, type DB, then the name of a collection if a collection is found within this database. We have created a collection of students. If this collection doesn't exist, one will be created for you. db.students. We will use the insert one method. Within the set of parentheses, we will place a document, which is enclosed within a set of curly braces. Within the set of curly braces, we can list as many field value pairs as we would like. Let's create a name field with the value of SpongeBob. Each field value pair is comma separated. Let's add another field value pair. Maybe an age. Age will be 30. Then a GPA, grade point average. SpongeBob has a solid 3.2 GPA. Let's enter this command. That was acknowledged. To return all documents within a collection, type db, the name of the collection, in this case students, we can use the find method. Here are the current documents within my collection. We only have one. Here's the object ID that's created automatically. The name is SpongeBob, age 30, GPA 3.2. Now you can insert more than one document at a time by using the insert many function. db, type the name of the collection, students in this case. We will insert many documents. We will place all documents to be inserted within an array. Add a set of straight brackets. This is the exact same kind of array from different programming languages. However, in Python, I think that would be a list technically. Maybe we need to insert 3 documents. We would need 3 sets of curly braces, each comma separated. Within each set of curly braces, we would list all of the different field value pairs. So let's begin with the first. We have name, Patrick. Separate each field value pair with a comma. Then we have age of, let's make Patrick 38. Then GPA. Patrick is at 1.5. That's enough for our first document. Let's go to the second document. Move over to the second set of curly braces. For the name, this will be Sandy. Sandy's age is, 27 sounds good. GPA, Sandy smart. She has a solid 4.0. Then let's go to the last document. Name, maybe Gary. Gary's age is 18. GPA, 2.5. That's good enough for now. This array contains several documents. Each document is enclosed within a set of curly braces. Within each document, you can have as many field value pairs as you like. They all don't need to be consistent. Let's insert all of these documents. They were all acknowledged. We have 3 new object IDs. Let's use the find method again to display all of them. db.students.find. Here are the 4 objects found within our database. SpongeBob, Patrick, Sandy, Gary. That's how to insert documents using the shell. Next, we'll do the same thing, but use Compass instead. If you're using Compass, here's how to insert documents into a collection. Here are the 4 documents we created previously. I'm just going to go ahead and delete these. To add a new document, make sure you're within the current database you're working with. Go to the current collection. Ours is students. We will add data. You can import a JSON or CSV file, or you can type them manually by inserting document. A document is pre-generated for you. I'm just going to go ahead and delete that. We'll begin by inserting SpongeBob. You need a set of curly braces, then list all of the name value pairs. Name SpongeBob. Separate each field value pair with a comma. Age 30. GPA 3.2. If you have this warning, you will need to probably hit the format button. That should go away. Then insert. And that is how to insert one document. To insert many, it's the same process as before. But you're going to enclose all of your documents within an array, a set of straight brackets. So if we need 3 documents, add 3 sets of curly braces, all comma separated. We had Patrick, Age, I think he was 38. GPA, 1.5. Name, Sandy. Age, 27. I'm going to move this down a little bit so you can see. GPA, 4.0. Then name, Gary. Age, 18. GPA, 2.5. Let's reformat, insert, and here are the 3 documents we have inserted. All right, and that is how to insert documents into a MongoDB database using Compass. All right, everybody, it's about time I discuss some basic data types in MongoDB. We will begin by inserting a new document into our students collection, db.students.insert1. We're inserting a document, add a set of curly braces. The first data type I'll discuss is a string. Suppose we have a field of name. A string is a series of text within quotes. These can be either double quotes or single quotes, but typically I like to put them within double quotes. A string is a series of text, like a name, like Larry. Strings can contain spaces. We could enter in a first name, space, then a last name, Larry Lobster. They can also contain numbers, Larry 123. However, in a string, we treat the numbers differently. We read them more as characters, rather than actual numbers. So let's stick with name Larry. That's a string. It's a series of characters. Then we have integers. An integer is a whole number. Let's create a field for age. Larry will be 32. Whole integers don't contain decimal portions. It wouldn't make sense to enter in 32.5. We don't really keep track of people's half birthdays and stuff. So age would be a whole number. Those are integers, whole numbers. Then we have doubles. A double is a number that contains a decimal portion. Maybe a grade point average. Grade point averages typically contain decimals. Larry has a 2.8 GPA. It's a double because there's a decimal portion. Integers are whole numbers. Doubles are numbers that contain a decimal. Then we have booleans. Booleans are either true or they're false. It's kind of like a light switch. It's only on or off. There's only 2 states. Let's create a field for full-time. Is the student full-time? This can be either true or false. Larry is too busy working out all the time. He is a part-time student, not a full-time student. We'll set that field to be false. Date objects are pretty popular in MongoDB. Suppose we have a registration date. Register date. To create a date object, you can use the new keyword, followed by a call to the date constructor. If you don't pass any arguments to the date constructor, you'll use the current time in the UTC time zone. Otherwise, you can pass a date and time, like 2023, January 2nd. You could add a time too. But we'll just stick with the current date and time that's assigned to us. Those are date objects. The next data type is null. Null means no value. I'll create a field for a graduation date. And I will set that to be null. Larry is a current student, but we don't know when he's going to graduate. All we're really doing is creating a placeholder. We don't have a date yet, so we can set that to be null. That's to be filled in later. So null means no value. Then we have arrays. Much like in modern programming languages, is kind of like a variable that has more than one value. But in MongoDB, we have a field that can have more than one value. Let's create a field of courses. What courses is Larry enrolled in? Place all values within a set of straight brackets. Let's insert multiple values. What courses is Larry in? Maybe he's in biology. These values are all comma separated. Chemistry. Then calculus. So that's an array. They're all enclosed within a set of square brackets. They allow one field to contain multiple values. Then we have nested documents. This would be good for an address. To create a nested document, you use a set of curly braces. Within the nested document, we can list some field value pairs. How about a street? Let's come up with a street name. 123 Fake Street is good. Then a city. Bikini Bottom. and a zip code. 1, 2, 3, 4, 5. It is possible to have documents within documents, which is what we did with the address. Let's enter everything to see if it works. Yeah, that was acknowledged. Let's head to Compass, refresh, and here is Larry. Name, Larry, age 32, GPA 2.8. Full-time is set to false, he's a part-time student. Here is Larry's registration date and time. We're using the UTC time zone. His graduation date is set to null. All of his courses that he's in is stored within an array, and his address is stored as a nested document. Alright everybody, and those are a few basic data types you should know in MongoDB. Alright everybody, today I'm going to show you how we can both sort and limit documents in MongoDB. To return all documents, we can type db, the name of the collection, dot, then we can use the find method to return all documents. To sort these documents in some sort of order, again, we would type db, the name of the collection, students, dot find method, then we'll do some method chaining. After the find method, add dot, then we will call the sort method. The sort method takes a document. By which field would we like to sort? Let's sort names in alphabetical order. We would type the name of the field, name, colon, then 1 for alphabetical order, or -1 for reverse alphabetical order. So if we were to sort by alphabetical order, here's the results. We have Gary, then Larry, Patrick, Sandy, SpongeBob. Then reverse alphabetical order, that was name, colon, -1. Now we have SpongeBob, Sandy, Patrick, Larry, Gary. Let's sort our documents by GPA, grade point average. So again, we use the find method, then we'll method chain the sort method. We're passing in a document object with our criteria. We will sort by GPA in ascending order, so we will use 1. I'm going to copy this because I'm going to use it later. Okay, now we're sorting by GPA. Patrick has the lowest GPA, 1.5, 2.5, 2.8, 3.2, then 4. To sort our GPA by descending order, we would type GPA -1. Then we have Sandy at the top with the GPA of 4, then SpongeBob with 3.2, 2.8, 2.5, 1.5. Now we have the limit method. We can limit the amount of documents that are returned to us. Let's type db.students.findMethod .limit method. We will pass the number of documents we would like returned to us as an argument. If I would like 1 document returned to us, I will pass in 1. Currently, my documents are sorted by object ID. This would give us the first document of SpongeBob. If I were to use limit 3, we would be returned 3 documents: SpongeBob, Patrick, Sandy. We can combine both the sort and the limit methods too. I would like to return the student with the highest GPA. We'll use the find method, then method chain the sort method. We are sorting by GPA. We're going to sort in decreasing order, so -1, followed by the limit method. I would like just 1 document. Who has the highest GPA? That would be Sandy, with a GPA of 4. Who has the lowest GPA? We should sort in increasing order. That would be 1, then limit 1. So Patrick has the lowest GPA of 1.5. Now let's work with sorting and limiting in Compass. To sort the documents in your collection, you can press More Options, then add some sort criteria. I will sort by name. Name, colon, 1. Then find. So we have Gary, Larry, Patrick, Sandy, SpongeBob. Then -1 for reverse alphabetical order. SpongeBob, Sandy, Patrick, Larry, Gary. Let's sort by GPA. GPA -1. That would give us decreasing order. So Sandy's at the top. To limit the amount of documents that are returned, you can enter in a number for the limit box. I will limit the records to 1. So we are returned with Sandy. She has the highest GPA. Limit 3 would give us the top 3 students. Or leave limit empty to return all documents. Alright everybody, so that is basic sorting and limiting in MongoDB. Hey everybody, in this topic I'm going to explain the find method in MongoDB. To use the find method, type db, the name of the collection you're working with, then add the find method. That will return all documents within this collection. But at times you might not want all documents, you might want specific documents. Here's how. We will add some arguments to the find method, db.students.find. The first argument is a document object. The parameter is the query parameter. It specifies selection filters. Maybe you just need one student. Well, you would just list that criteria here. I would like any students with the name of SpongeBob. That would return any document where the first name is SpongeBob. That would return everybody that has that name. I'm just going to copy this. Let's find any students that have a GPA of 4.0. Within our document, the search filter is GPA 4.0. That would give us Sandy. Let's find if any students are not full-time. Full-time, I will set that to be false. There is one student. Larry, full-time is set to false. The query parameter is very similar to a where clause in SQL. You can even use more than one filter. Search for any student that has a GPA of 4.0. Each filter is comma separated, as well as full-time being true. With my dataset, this does not return any results. But to add more than one filter, they're comma separated within a document body. With the find method, there is a second parameter. That is the projection parameter. We would pass another document body. They're each comma separated. If you don't specify the query parameter, you would just return all documents. With the projection parameter, you can return specific fields. Maybe you don't want all the information that's available. Perhaps I would just like each student's name. So we would set the field to be true. You can use one as well, but my own preference is true, just because it's more readable. Return every document, but only give their name. And here they are. MongoDB will give you the ID regardless. You can set that to be false within the projection parameter. Underscore ID, false. I just want everybody's name. There we are, SpongeBob, Patrick, Sandy, Gary, Larry. Let's get every student's name as well as their GPA. So ID, I will set that to be false. I don't want that. Name will be true. I would like that. GPA will also be true. I would like that. Here is every student's name as well as their GPA. So that's the projection parameter. If there's a field you would like or don't want, you can set that to be either true or false when you display your data. All right, let's do the same thing with compass. With compass, this text box is for the find method. So within a set of curly braces, I would like to find any name that's SpongeBob. Then press find. That returns one result. Return any student with the GPA of 4.0. That's Sandy. Return any students that are not full-time. Full-time is false. That gives us Larry. Now, if you go to more options, there is a projection parameter if you only want some data. Let's find every student, but for the projection parameter, I would only like their name. I'll set that to be true. And their GPA. That's true as well. Again, that still gives us the ID. Let's set that to be false if you don't want that. ID, false, and that should get rid of the IDs. Here's each student's name and their GPA. All right, everybody, that's the find method. Two optional parameters that we can send arguments to are the query parameter. That's selection criteria. It's similar to a where clause in SQL. We're trying to limit the results. And the projection parameter, that's similar to selected columns in SQL. You're looking for specific fields. All right, everybody, and that is the find method in MongoDB. Well, hello again, everybody. Today I will be explaining how we can update documents in MongoDB. To do that, we would type db, the name of the collection we're working with, in this case, students. We can either update one document or update many. Let's update one. We will use the update one method. There are two parameters set up, filter and update. Filter is the selection criteria for the update. So within a set of curly braces, we will pass some criteria. Let's update anybody's name that's SpongeBob. It's basically just selection criteria. The second parameter, it's another document body, is the update parameter. What are the modifications we would like to apply? We will utilize the set operator, which is preceded with the $sign. The set operator replaces the value of a field. So after the set operator, add a colon, then another set of curly braces. Yes, there's a lot of curly braces in MongoDB. So within this set of curly braces, after the set operator, that's where we can make our changes. You can add or change the value of a field. SpongeBob doesn't have a full-time field. We can add that with the set operator. If this field already exists, we would update it. So let's say SpongeBob is a full-time student. Let's execute this command. It was acknowledged, that's true. We have a matched count of 1 and a modified count of 1. Let's take a look at SpongeBob. db.students.find name SpongeBob. And here he is. He is now a full-time student. With your filter argument, if you're working with a large data set, it is possible that two people can have the same name. It would be safer if we were to update by an object ID. These IDs are unique for each document. Let's update, but with the filter, we will search by object ID. So again, that's db.students.update1. First is the filter parameter. Within a document body, let's select underscore ID colon, then paste that object ID for SpongeBob. For every document, the object ID is unique. Just in case there's two people named SpongeBob, we won't update it. Looks like I have double underscore ID. Let me fix that real quick. Otherwise, we'll get a syntax error. So select the document that has this object ID. Then the second argument, which is comma separated, will be the changes to be made. So we will set colon, another set of curly braces. Let's set full time to be false. SpongeBob already works a full-time job. He'll just be a part-time student. Okay, that was acknowledged. Let's take a look at SpongeBob again using the find method. db.students.find ID colon the unique object ID. And here's SpongeBob. The full-time field is set to false. Before it was true, but we updated it. Now you can unset a field too. Let's get rid of the full-time field for SpongeBob. db.students.update1. We will search by ID. Then for the second argument, we will use the unset operator, which will remove a field. So within another set of curly braces, let's take our full-time field, colon. Now to remove a field, for the value, just set it to be an empty string. Let's take a look. That was acknowledged. Let's select SpongeBob again. db.students.find. All right, and here's SpongeBob again. That full-time field is gone now. You can use the unset operator to remove a field. Now let's talk about update many. Using the update many method, we can update many documents at once. db.students.update many. This method has the same parameters as update1. If I would like to select every document, I will use an empty set of curly braces. What are the changes we would like to make? Let's use the set operator. Let's set everybody's full-time field to be false. If they don't have this field, one will be created for them. All right, let's find every student. That was acknowledged. db.students.find everybody. Everybody should have a full-time field that's set to false. Full-time is false. Here as well. Yeah, and that applies to everybody. All right, let's unset the full-time field for Gary and Sandy. db.students.update1. Let's select name, Gary. We will use the unset operator. then add the changes to be made. Full time, then we'll remove it by placing an empty string. I'm going to copy this line. We'll reuse it later. That was acknowledged. Then let's remove full time for Sandy. That was acknowledged as well. So let's double check db.students.find. So SpongeBob and Patrick both have this full-time field. Sandy and Gary don't. They were unset. With the update many method, we can check to see if a field exists or doesn't exist within the selection criteria. If any student doesn't have a full-time field, let's update it. db.students.updateMany. What is the selection criteria? Let's say the selection criteria is full-time field. Does it not exist? We will use the exists operator. Exists preceded with a $sign. Then add false. Does this full-time field not exist? That's the selection criteria. If a document doesn't have the full-time field, we'll give them one. So the second argument will be the changes to be made. We will use the set operator, colon, another set of curly braces. Anybody that doesn't have the full-time field, let's set that to be true. Full-time, true. Press enter. That was acknowledged. Let's take a look at our students, db.students.find. All right, so Sandy and Gary are both full-time students now. SpongeBob, Patrick, and Larry are not full-time students. They're part-time students. That's how to update documents in the MongoDB Shell. You can use update one or update many. Let's do the same thing with Compass. Hello again, everybody. In Compass, to update a field of a document, you can press the pencil icon to edit the document. To remove a field next to the field name, you can press the trash can icon to remove it, then update. To add a field, go to the pencil icon again. After a field, you can add a new field by pressing the plus button to add a field. Let's add a full-time field. For the value, I will set that to be false for SpongeBob. Then you can change the data type here. We'll change that to be a Boolean. Then update. To change a pre-existing field, again go to the pencil icon, select your field, then you can change one of the values. But I'll keep this as false. That is how to update documents in Compass. It's fairly easy and straightforward. Alright everybody, so that is how to update documents in MongoDB. You can use the update one method or update many. You pass in a filter for the selection criteria, then the modifications within the update parameter. And that is how to update documents in MongoDB. Hello again, friends. It's me again. Today I will be explaining how we can delete documents in MongoDB. Before we do begin this lesson, I recommend exporting your collection. We'll be deleting documents. Adding them back in is kind of a pain in the ass unless we're importing them. So let's export our collection. Export query with filters, that's fine. Select output. You can export as a JSON file or as a CSV file. Let's export our collection as a JSON file. You can also select a destination. I'll place this file on my desktop just for convenience. And export. We'll be importing this JSON file at the end of this lesson. And close. Within Compass, to delete a document, all you do is press the trash can icon, then delete. It's really easy in Compass. In the shell, it's a little different. In the shell, to delete a document, type db dot the name of the collection, students, then there's delete one or delete many. We'll begin with delete one. We have one parameter, a filter parameter. It's very similar to the find method. We list some criteria to search for. Let's delete anybody with the name of Larry. That was acknowledged. The deleted count is 1. Let's find our students, db.students.find. And Larry is no longer at the bottom. We have Patrick, Sandy, and Gary remaining. We can use delete many to delete more than one document. db.students.deleteMany. Pass in our criteria. Anybody that has a full-time field set to false will delete. So we have deleted one person that matches this criteria. db.students.find. We have deleted Patrick. We can delete any documents that are missing a field. Or if a field does exist, we can delete that. Let's delete any document that is missing a registration date. db.students.delete many. We are checking if there is a registration date field. Does this field not exist? If it doesn't, then delete that document. We will use the exists operator, false. If this field doesn't exist, delete that document. So we have deleted two documents. If we take a look at our students now, db.students.find, we no longer have any students. So that's how to delete one or many documents with the MongoDB shell. Now if we head back to Compass, then refresh, we have no more students. Let's import our collection that we exported because we do need some data for this series. Add data, import JSON or CSV file. We are looking for our students JSON file. Select and import. And we're done. So that is how to delete documents in MongoDB. Hey everyone, today I need to explain comparison operators. Operators are denoted with the $sign. Comparison operators return data based on value comparisons. In previous examples, we would type db.students.find, then list some criteria. Like if we're looking for SpongeBob, we would say name, SpongeBob. Now, what if you would like to find everybody but SpongeBob? Well, you can use the not equals comparison operator. We would enclose it within a document body, precede our value with the not equal comparison operator, $NE, find every name that's not SpongeBob. That gives us 4 records: Patrick, Sandy, Gary, Larry. SpongeBob isn't within here. That is the not equals comparison operator. Return every document that has a name not equal to SpongeBob. Let's go over a few more. Let's cover less than and less than equals to. db.students.find. Find everybody that has an age that is less than, so $LT for less than, 20. That gives us one document, Gary, who's 18. Or we could use less than equal to. Change LT to LTE. That means our 20 is inclusive. Maybe let's change this to 27. Return every document where the age field is less than or equal to 27. That would give us 2 results. Sandy, who's 27 exactly, and Gary, who's 18. Let's do greater than. Return every document where age is greater than 27. That gives us 3 documents. SpongeBob, who's 30, Patrick, who's 38, Larry, who's 32. Let's do greater than equals. That would be GTE. Find everybody that's greater than or equal to 27. That gives us 4 records: SpongeBob, Patrick, Sandy, who's 27 exactly, and Larry. So that's less than equals to, greater than, and greater than equals to. You can use more than one comparison operator to find values within a certain range. Let's find every student whose GPA is between 3 and 4. db.students.find. We are searching for GPA. Let's use the greater than equals to comparison operator. Return every GPA that's greater than 3, comma, and less than or equal to 4. So these would be the students that have a good GPA. SpongeBob and Sandy. SpongeBob has a GPA of 3.2. Sandy's is 4.0. You can use more than one comparison operator to give you a range. Now another good operator is the in operator. With the in operator, we can return all records that have one of these matching values. So db.students.find. Let's find any student whose name is within this array. We will pass in a document body, use the in operator, colon, then list an array of values. Let's find anybody whose name is either SpongeBob, Patrick, or Sandy. So within an array, we will list our values. Return anybody whose name is SpongeBob, Patrick, or Sandy. There, SpongeBob, Patrick, Sandy. With the in logical operator, you will return all documents where one of the values in this array is found within this field. You can also use not in, which is nin. So let's copy this line, clear our screen, paste it, change in to nin, not in. Return all documents where name doesn't have one of these values. That would give us Gary and Larry. We are given everybody's name that's not SpongeBob, Patrick, or Sandy. Let's switch to Compass, and I'll show you how we can do the same thing. Within Compass, you would write your filter within this text box. Return everybody who has a GPA field that is greater than or equal to 3. GTE 3. That gives us SpongeBob and Sandy. Give us everybody whose, let's say, age is less than 27. That gives us Gary. All right, everybody, so in conclusion, comparison operators return data based on value comparisons. And those are comparison operators in MongoDB. Hey everybody, today I need to explain logical operators. Logical operators return data based on expressions that evaluate to be true or false. There's 4: and, or, nor, and not. Let's begin with and. Using the and logical operator, we can check to see if 2 expressions are true. Let's begin with db.students, that's the name of the collection. We'll use the find method, pass in a document object. We will use the and logical operator. It's preceded with a $sign. It's an operator. Then a colon. Whatever expressions you would like to check, you will place within an array. List as many expressions as you would like. Let's return any document where the student is a full-time student and they're 22 years or younger. Usually most students, when they start college, they're between the ages of 18 and 22. So let's find all those students. We'll have 2 conditions. We need 2 document bodies. Our first condition is full-time true. Give me any student that's a full-time student. And our other condition is give me any student that's age is less than or equal to 22. We'll use the less than equals comparison operator, colon, 22. And that's it. We have 1 student, Gary. He's 22 and under, and a full-time student. So with the and logical operator, you can have more than 1 condition. This condition needs to be true, and that condition needs to be true. We were given the result of Gary. He's the only student that passes these 2 filters. They both evaluated to be true. Let's copy this method, we'll reuse it. Let's discuss or. Change and to or. With the or logical operator, at least one of these conditions need to be true. Give me anybody that's a full-time student, or anybody that's 22 or younger. That will give me 2 documents. Sandy, she's older than 22, but she's a full-time student. Gary is 22 and under, and a full-time student. So with the or logical operator, at least one condition needs to be true. So again, let's copy this method, we'll reuse it. Then we will talk about nor. So with the nor logical operator, NOR, we will return any document where these conditions are false. This needs to be false, as well as this needs to be false. It's kind of like and, but instead of both conditions being true, it's the opposite. They both need to be false. So that would give me 3 results. SpongeBob, he's above 22. He's a part-time student. Patrick is 38. He's a part-time student. Larry, he's 32. He's a part-time student. With the nor logical operator, we need both of these conditions to be false. That gave us these three documents for SpongeBob, Patrick, and Larry. Lastly, we have not. Suppose I have this query, db.students.find, find any student that is not above 30. I could write something like this, age, colon, we'll use the less than comparison operator, colon, 30. Find any student under 30. Normally, this would give me Sandy and Gary. You know, this does work, but what if somebody doesn't have some information for their age? Like, let's change Gary's age to null, because in SpongeBob lore, Gary is a pet snail. His age is in cat years. Just to make this easy in Compass, I'm going to edit Gary's age to be null. Let's write that query again. Give me any student whose age is less than 30. Well, that only gives me Sandy. Gary's age is null. So another way in which we could return all students that are not 30 or above, we can use the not logical operator. The not logical operator reverses what you're looking for. So let's enclose this document body within another document body. Then we will use the $not logical operator, but we will change the comparison operator to be greater than equals. Give me any student that is not greater than or equal to 30. So that should give me both Sandy and Gary, even though Gary's age is null. In many circumstances, you could use less than, but a benefit of the not logical operator is that it would give you null values. Return any document that doesn't fit this condition. Basically speaking, not just does the opposite. All right, everybody, so those are logical operators. They return data based on expressions that evaluate to be true or false. And those are logical operators in MongoDB. Hey everybody, today we are moving on to indexes. An index allows for the quick lookup of a field. However, it takes up more memory and slows insert, update, and remove operations. Use them wisely. Utilizing an index, if you're familiar with data structures and algorithms, we are storing our data as a B tree. If there's a field you search for, but you don't do many updates, I would recommend an index. Here's an example. Let's find any students named Larry. db.students.find. Find anybody named Larry. I'm going to make one adjustment though. Let's method chain the explain method and pass in this string, execution stats. That will give me the execution stats of this query. I have 5 documents within my collection. We have examined 5 documents to find Larry. We're performing a linear search through our collection. We're examining each document one by one. I only have 5 documents. That wouldn't take too long. Imagine I have thousands or hundreds of thousands of documents. Well, a linear search is going to take a really long time. We can speed up the lookup process by applying an index. To apply an index to a field, you would type something like this. db dot the name of the collection dot create index. Now, what field would you like to apply an index for? Let's apply an index to our name field. Name, colon. You can arrange the data in your index in ascending order by using 1 or descending order with -1. So with a name, 1 would be alphabetical, starting with A to Z. Let's hit enter. This is the name of our index, name_1. Let's perform that query one more time. db.students.find. Find anybody named Larry. Name, Larry. Then we will method chain the explain method. Pass in the string execution stats. Let's see what the results are. This time we only examined 1 document. Examining 1 document is a lot less time consuming than examining 5 documents. Like I said, I have a small data set. It doesn't appear to make that big of a difference, but if you have hundreds of thousands of documents, it's going to save you a lot of time. To get all your indexes, you can use the getIndexes method. db.students.getIndexes. And we have 2. There already is an index applied to object IDs. We have that by default. And here's the index we created to look up names quickly. we have two indexes technically. To drop an index, you'll need the name. Let's copy that. db.students.drop index. Place the name of the index within the drop index method. And our index is dropped. Let's take a look at our indexes again. db.student.getIndexes, and our index is gone. Now, if you would like to create an index in Compass, you go to the Indexes tab, create index, select a type or field name. Let's create an index for name. Select a type. Let's place our name in ascending order. You can select more options, but that's a little advanced for us at this level. Let's begin with the basics. And that's how to create an index in Compass. Then to drop the index, you just press this trash can icon. Type the index name, name_1, and that's how to drop an index. So in conclusion, applying an index to a field allows for quick lookup of that field, but it takes up more memory and it slows insert, update, and remove operations because you have to update the binary search tree. Use indexes wisely. Personally, I would recommend an index if you're doing a lot of searching, but not a lot of updating. So that's an introduction to indexes in MongoDB. Hey everybody, with the last few minutes remaining of the MongoDB in 1 hour series, I thought I'd get a little more in depth with collections. As we've learned at the beginning of the series, a collection is a group of documents, and a database is a group of collections. Within your database, to show collections, you can type show collections. Currently, we only have one, students. Let's create another though. Let's create a collection of teachers. We'll use the db.create collection method, pass in a name for this collection. Let's create a collection of teachers. So this would work. However, there are some additional options that we can pass in as arguments to this method. Let's add the next argument. It's comma separated. Another argument that we can pass into this method when creating a collection is a max size for this collection. We will set the capped field to be true. That's informing MongoDB this collection should have a maximum size. This field is either true or false. If capped is set to true, you do need a minimum size specified. So size, that's a field. Then set a size in bytes. If you would like a maximum size of 10 megabytes, that would be 10 million. 10 million bytes. Let me count my zeros. Yeah, that's accurate. And or you can have a maximum number of documents. You will set the max field to be some amount of documents. I don't want any more than 100 teachers. Our collection has a maximum size of 10 megabytes. We've also set that there can be no more than 100 documents in this collection. We don't want any more than 100 teachers. There are a few more advanced options for collections, but that's beyond our level right now. But another you may be interested in is auto index ID. So that is a separate argument. It's comma separated. We need a document body, auto index ID. This is either true or false. Based on indexes in the last topic, automatically we apply an index to object IDs, but we can toggle that to be true or false. There are some pros and cons with indexes. An index allows for quick lookup, but any write operations are a little bit slower. I'll set auto index ID to be false. Let's execute this command. All right, that was approved. Let's show our collections. Show collections. And we have two collections. A collection for students and a collection for teachers. Hey, let's create one more for practice. Let's create one more collection. db.create collection. What's the collection name? Let's create a collection of courses, like what classes can we take at our school? That was approved. Let's show our collections. And we have 3, courses, students, teachers. Then to drop a collection, you type db, the name of the collection. Let's drop our courses dot drop method. That was dropped. Let's show our collections again. And we are back to 2 collections, a collection of students and a collection of teachers. All right, everybody, that was MongoDB in 1 hour. Hey, if you've made it this far, be sure you've smashed that like button, leave a random comment down below, and subscribe if you'd like to become a fellow bro.